Hello, everyone, and welcome to the SMPTE Philadelphia presentation, sponsored by AVT. And NewTek will be presenting on NDI, the other IP format. We have Kane Peterson, Jeremy Morris, and Carl Cavagnolo from NewTek. They've all been professionals in the TV industry for their entire careers in a variety of client-facing technical positions. It's with this understanding, the issues users currently face, that we put together this timely presentation to help you appreciate how IP technology and NewTek's NDI technology can be part of adapting to this new reality. To start off the presentation, I've invited Ashley from AVT, who's helping present this and put this on, to say a few words about AVT.
Sure, thanks, Mark. Yeah, thank you, Mark. We're happy to help coordinate having NewTek present today, and we're happy to sponsor events like this. I just quickly, we're Applied Video Technology. We've probably worked with quite a few of you on this call. We are an elite NewTek partner and have been for quite some time, so we're excited to see the future of NDI and where a lot of the products are headed. We are based out of Kimberton, Pennsylvania, so we have we've been in business since 1996. We're a full AV audiovisual systems integrator. We do a lot with the broadcast industry and video production. Like I said, we're one of the NewTek Elite partners, and we have been for, we've been named one of their top partners for 2019 just recently. So we're pleased to work with SMPTE and with NewTek, and we can share our contact information for any questions that anyone might have, either for Applied Video or with NewTek for this, after this for follow-up. So thanks again for having us, and I'll hand it back to you, Mark. And I will stop sharing my screen.
Sorry about that. I have to unmute my mic. To let everybody know, AVT is sponsoring us again. We also, the Q&A is not working for this session, so if you can send an email to us on the email you got from the SMPTE at outlook.com, and we'll try and answer them as quickly as possible, as best as possible. I'm going to turn it now over to Carl, who's going to start the presentation off. Carl?
Hi, everybody. So I wish I was actually on the Teams meeting with you. I called in about an hour ago. We had a tree fall in the area, and it took down power, so I had to scramble a little bit. But the good part is that I, like you, had a disaster recovery program in mind, and I had a cell phone and a car and a 12-volt battery, and here I am. So sort of to begin this whole thing, there's 3 folks on this call from NewTek. We've got Jeremy Morris, who's out in suburban Maryland. We've got Kane Peterson, who's over in the Chicago area. And I'm in the Hudson Valley of New York. And what we're going to do is we're going to break this presentation really into 4 parts. What I'm going to be doing is starting it off and sort of creating a narrative as to what our current situation is. When I say our current situation, I mean our current shared situation as users as in an industry. And what we're going to do then is to segue over to Kane. And Kane's going to talk a little bit about NDI, what exactly NDI is, and what its applications are, and why it was invented. And then we're going to talk about some of the tool sets that are available for NDI, and we're going to focus on free tool sets because, I'm a board member of the SMPTE in New York, and I hate when people make marketing applications out of these things. So we're going to talk about those free aspects that people can utilize today just by going to the website and picking them up. And then Jeremy is going to actually take it a step further, and he's going to actually show you examples of these tool sets working and how you can implement into your facilities. And the last part will be sort of a question and answer. So as we all know, this whole new world of ours sort of began in March. And it was a strange time, and then all of a sudden we were all hit with a new way of really running our businesses. The problems really began to become exposed right from the very beginning, and it's kind of funny too. because in March, we had, for years we've had a product called Talk Show, and it was a Skype TX product, and it allowed people, remote users, to sort of dial into an environment, and they'd become baseband video applications. And the phone started ringing off the hook for people sort of needing this kind of solution. And it was the same sort of conversation that we were having with everyone. It was, we need to protect the talent. The on-air people need to be protected. They can't find themselves in being sick and all this sort of stuff. And as important that is, the first thing that I started thinking about after the second or third call was, geez, who's thinking about all the production people? The production people are all sort of encamped in control rooms. They need to sequester, get their jobs done. And it really wasn't just an issue of the talent. And so that sort of led to a lot of interesting conversations about remote control applications, remote utilization, not only bringing content in from the outside, but being able to produce content in a remote sort of way, where the equipment may be sort of residing in a centralized control room, yet the operator is at home, miles away. And so we sort of focused in on that. We focused in a little bit on, bringing in remote content through Skype. And things started to gel a little bit. And for the most part, the broadcasters were fairly well positioned for this. The broadcasters had, live view applications that they could run on their iOS, and they could bring in the talent. But it didn't really extend itself to outside their own business model. If you wanted to bring in Warren Buffett for some sort of conversation about finance, he's certainly not going to load some strange app on his mobile device. So we needed ways of communicating with people outside. And so for the broadcaster, it was a little bit simpler, I think, than the preponderance of the people that are out there. For the broadcaster, they had those tools in place. Their first worry was about getting more PCs and worrying about network security when you sort of extended your reach to people's homes. But, they made some compromises, and they got the operation working. And in all honesty, a lot of the remote stuff has been in the hands of the broadcasters for a while. If you've got a production automation system, you can extend the reach of that through a WAN, or you could through the internet and things of this nature, and have operators at home. But but the problem was that in order to do that, you needed a $150,000 or a $250,000 system, depending on the level of redundancy, and you needed a really big production switcher. And a lot of people really weren't sort of in that position to be able to manage their needs in a remote sort of way. So those issues that sort of came up right away, and it's funny, the problems existed not only for people who had baseband applications, but those people who had 2110 facilities as well, since the reach out of house for a 12 gig carrier didn't really play well for for home use or for remote utilizations. So how do you get those things like graphics? How do you create graphics externally and then get them back into the system? How do you manage when somebody needs multi-viewers to see content that's being created and then doing it remotely, and you've got a baseband or a 12G network? How do you do that? How do you monitor master control? So those systems that were sort of considered to be bulletproof or sort of gold wrapped, although they performed well in-house, they didn't necessarily have the reach that the pandemic required. And so the focus on this is how you can use NDI as a tool to basically extend your reach, to be able to communicate across the internet, how you can manage your existing infrastructures in a remote sort of way. And I'm hoping that sort of sets the stage for Kane to take over and to begin his presentation.
Thank you. Let me switch over live so you can see me. Hello, everyone. My name is Kane Peterson. I actually am on the professional services side at NewTek, and I'm one of the main instructors at NewTek University. So I'm going to take you through a little more of a, I guess you could say, theoretical aspect of NDI, just talking about how the protocol works and some aspects of it here. Actually, many of these slides are out of, I do have a NewTek University class on NDI, so I've taken a very small sample because there's like, 6+ hours of content in that class. Obviously, we don't have 6 hours to spend here, but try to concise down a very, small version of what are the core pieces about NDI to know about. So let me take you through, and then of course after we're all done and Jeremy talks, we can try to answer questions. So NDI, if you're not familiar, stands for Network Device Interface. So that is what the letters stand for. And I'm going to kind of go from the standpoint of, let's pretend you don't know much about NDI at all. You've heard about it, right? It's a video IP protocol, but beyond that, you don't, it's like, I've never used it. So that's kind of the starting point here. So the first question usually comes up is like, well, how would you describe NDI? And I think in a very short description is that it's a royalty-free software technology for sending high quality, low latency video over standard Ethernet networks. And there's actually 4 key pieces in that one sentence. So royalty-free software, NewTek does not charge anybody to get access to the software development kit. They can include it in the software products they're building. They can sell them, distribute them. We do not, there's kind of no strings attached effectively there. We're talking about software when we say that. There is a hardware level development kit as well, or the embedded development kit as it's called. That one there is licensing for. So in case you've looked into it, I want you to come back and say, hey, there is some. But from a software standpoint, if you're making a computer application, it's free. It's high quality and it's low latency. So we're talking about video that looks and performs like SDI video. It is compressed. We'll talk about compression in just a little bit, but the compression is high quality compression. Nobody's going to look at this video and be like, what happened? What did you do to it? It's going to look like video they're used to looking at. Low latency, typically for most cases, we're talking 1 frame of video or less for transmission time. So you could run this alongside SDI and people are not going to see the difference of what's going on. And by standard Ethernet networks, we are talking about 1 gig Ethernet being the target here. Now, there are cases that it can run on less, that we can even make it run over Wi-Fi or less than gigabit, and certainly can take advantage of better than gigabit, right? 10 gig and stuff like that. But 1 gig is really all you need to make it work in most situations. And we have lots of people out there producing entire events, and all they have is 1 gig networking. Now, part of this is that, what we're looking for is, this is not a cable replacement, right? The goal of this is not to just say, let's replace our SDI cables with RJ45, Cat5, Cat6 cables. It's the enhancements it brings. It's what else gets added to your workflow by going this route. And NDI is not new, really. We're actually on version 4.5. It's been out for many years at this point, and we've already got thousands of companies that have downloaded the software development kit. There are already hundreds of products available in the market, and if you look at over all the years and everybody use it, there's been used by millions of people, because we're talking people both, gamers running in their basement, right, producing streams you watch on Twitch, all the way up to, if you name a 3-letter broadcast company in the United States, using it. And believe me, they're all using it. So there's a lot of range that this protocol goes from, literally the lowest of the low end to the highest of the high end that has seen use. Now, one of the questions might be, why do we want to do this? SDI has served us well for a long time. So what is the point? Why should we look at changing this out or looking at this as a future way? And Carl already covered on a lot, but I'm going to cover a few extras here. And this is not to say that these are the only reasons. These are just some reasons. And there's other reasons I don't have in this list. There's reasons that might apply to you that don't apply to somebody else. So just, there's just some of the reasons. A big one is flexibility. A lot of stuff is done on computers now, right? We're using PCs and Macs and Linux machines to deal with video, and you otherwise need to get I/O interfaces for them, and then what kind of I/O interface determines how many channels of video it can work with and what video formats it can bring in and bring out. With this, I don't need any of that. I plug it into the network, and all of a sudden this computer can now deal with multiple channels of video in and out simultaneously. So the ability to just use computers, buildings are already wired for networking, so you don't have to be running network cables around or video cables around, right? The network cables are already in place in a lot of facilities, make it very flexible to start working with it. It's extensible, right? We can make it do new stuff as time goes on. So from when NDI 1.0 to where NDI 4.5 has come out, we've added new features and new functionalities to it with new support for new compression protocols, PTZ support, the ability for remote sources, all sorts of things have been added to it over the years. And that's not to stop, it will continue on, but it's certainly much easier to extend an IP protocol with new functionality in the future based upon needs and capabilities that clients and workflows require. The cost. Now, I know some people might say, well, an NDI piece of equipment might cost more than a traditional piece of equipment, but if you look at the overall workflow, there's actually advantages that can come into place and costs can be achieved. Network gear is typically less expensive than traditional, proprietary video gear. A network switch is orders of magnitude cheaper than a video router would be, and in general also much more flexible at the same time. Network cabling is also generally less expensive. So when you start looking at the big picture of everything, cost can be achieved for a large scale facility because you can start taking advantage of all of this off-the-shelf technology and stuff that you might already have in place as well that you don't have to necessarily go out and buy and start building up your equipment. Compatibility, it's not just NDI. I mean, really the key part here is that its IP is the underlying technology behind all of this. And we can run other things across it besides NDI. We can run Dante Audio, AES-67, other protocols, HTTP for control and other data formats and stuff. So all of this can be, shared on that same infrastructure. So again, allowing it to be less expensive because you don't have to be running more cables and more type of infrastructure to support these other types of things. And compatibility can be achieved as well. As new systems come out, we can still have them be backwards compatible or even have software upgrades that can take older systems and make them do newer things. So there's a lot of advantages from that standpoint. And then time is another aspect. Setting up a network, right? It's one cable, can run multiple channels of video. As I mentioned, buildings can already have networking in place, so you might not even have to run any cable to some degree. So there's a lot of things, even on a time standpoint, that can be saved by going with an IP infrastructure. Okay, so let's take a look at NDI. What does NDI itself offer as a protocol? So we've tried to build it as forward-thinking as possible. So it is resolution independent, frame rate independent, aspect ratio independent, number of audio channels independent, sample rate independent. All of these things can be defined. Now, I will admit, most applications and workflows are probably going to target a traditional video format because that's what we need to work with. But NDI itself is not limited to any of those things. You could have, there are people in Japan doing 8K with it already. You could do weird aspect ratios and all sorts of stuff. So it is set for what we need to do now, but also designed to handle stuff in the future as new things come out. It supports alpha channels. So alpha channels automatically built into the protocol. It becomes something you don't even have to think about. It's just there when you need it. It supports both video and RGB color space. It supports the ability to translate between them, and it can do that at up to 16 bits per pixel. So it's accurate color translation. Applications can be designed that can go up to 16 bits per pixel, so HDR can be handled by it today. That does mean, though, that the applications that you're building have to understand HDR as well. So it's not just that, hey, NDI supports HDR, everything does. It is that I have the ability to transport it, but obviously if I need to color correct it or do other things, the application on the other end needs to understand what this information means and how to process it. But again, NDI is ready to handle it today. Beyond traditional video, audio type information and alpha channel, right, we can also put commands in NDI, metadata, time code, tally information, PTZ, even custom data can be included. So again, all sorts of other information can be transported by it as well. So it's not just video and audio, it's virtually everything of your workflow could be encapsulated inside the NDI protocol. And it is supported virtually on everything. So there are the software development kit includes support for Windows, Macintosh, Linux. There's stuff for ARM-based development and also hardware development using FPGA for like embedded type devices. And they're all cross-compatible with each other, so all of this stuff can work side by side. All right. So NDI is actually available in kind of two major variants or formats. So you maybe, if you've looked into it, have heard a little bit about these. There is NDI, which we call high bandwidth NDI. This is the predominant method that is used. If it's a software application or an FPGA device, it's using this type of NDI. But there's also a version of NDI called NDI HX. And the HX actually stands for high efficiency. That's what the HX is designating. And this is typically used by hardware-only devices, although that's not exactly the restriction anymore, but certainly when it came out, it was. And the whole idea with this was that there were already devices on the market, PTZ cameras being a big one, but not the only thing, that had onboard compression circuitry, and we basically added this in so that we could adapt those existing devices to start spitting out a flavor, right, this NDI HX flavor of signal, so that you could take devices that were already in the field, like Panasonic and PTZ Optics and other companies, and basically install some new firmware on those devices, and all of a sudden they could start talking NDI. Now, to talk about these a little more in depth, NDI, the high bandwidth variant of NDI, uses a iframe compression structure. This means that every frame of video is compressed on its own. This allows for very low latency because of that, right? We can just compress each frame of video and immediately send it on. The compression structure uses what's called a DCT, or discrete cosine transform type compression. This is similar to the same kind of compression that you find in ProRes or DNX HD. So if you've worked with those protocols, and I'm sure almost everybody has, that's basically what NDI uses. It's our own variant tweak of it, but essentially that's when you get down to it, what is being used to compress the data structure down. The bandwidth used by NDI is set by your frame rate and frame size. This is not something that's a user dialable in adjustment. You basically say, I want to send a video frame that's of these parameters, and then NDI will say, well, this is how much bandwidth it will need to be. And I'll show you in a second here what some of those data rates typically are. Because this is an iframe only, we can get compression down to a frame or less. So in software applications, it's typically a frame. Maybe depends on, I guess, if we're talking a field, fielding or frames, right? If we're talking in fields, it actually works at fields. In hardware encoding, we can do it in less than a frame. We can actually start compressing at lines of resolution. So we've got converter boxes out there made by us and other companies like Magewell and BirdDog, where you can show an SDI and an NDI connection between devices, and it's the same frame of video showing up on the other end. And high bandwidth NDI, the target really for this is 1 gigabit networking, right? It's not designed to really run on less than that. There are some limited cases where you can make it work, but really for the most part, 1 gigabit is what you would use with this. Here are what some of the, for major video formats that we're used to, here are what some of the data rates are that are used by NDI. Now, these are targets, right? NDI does use a variable bit rate compression, so it's not like, exclusively this number. It can vary around, but typically this is what you would probably find realistic values being used. But again, if you send it a very simple picture, it will compress down more if it can. Now, NDI HX, which I mentioned, is a different flavor of NDI, and there's actually now two different types of NDI HX. There's NDI HX1. This uses an H.264 style long gop compression. It's much lower bandwidth, so about 15 megabits. Because of this long gop compression, the latency is a few frames, so it's a little bit latency. That's the trade-off, right? It's a little bit of latency for more compression, but because of this, it also works better in bandwidth-constricted connections. So like Wi-Fi, less than gigabit, or even WAN style connections can benefit because we're not trying to pass as much data through. There's also a newer variant of NDI HX called NDI HX version 2. This just came out last year, was when it was first supported. This is a tighter integration. So as I mentioned, NDI HX version 1 was really like, we took existing devices and we kind of, made new firmware to make them work. There was only so far you could go with that, right? Because these were devices that were already in the market. It's not like we could completely reprogram them. We could only program them to like, so much. So with NDI HX version 2, this is basically if you're making a new product and now you have the ability to, program everything about it because you're developing it, this is what you would use. And this allows for tighter integration with NDI. It supports more of the NDI functionality like groups and discovery server and stuff like that. And in fact, it is even possible for a software application to support NDI HX version 2 if they wanted that higher compression, algorithm to be used. Again, with the trade-off being a little bit of latency, but this is the other variant that's out there. Okay, now that we've talked about the types of NDI, let's talk quickly about how does NDI talk on your network, right? How do devices find each other? How does this process operate? So NDI has a built-in discovery and registration mechanism built into the system, and then it also, once this is handled, it then also sends the transmission. So it's really a complete protocol in the sense that it's, finding devices, it's registering who's out on your network, and handling the communication. So it's handling the whole aspect of everything you need in here. So let's imagine that this circle you're looking at is a computer network, right? It's just, thought, version of it. It's not a Tolkien ring network. I don't want you to think I'm talking about Tolkien ring here. And imagine we've got an NDI device on it, right? Doesn't matter what it is. It's just some NDI device. And we have, let's just say, our video switcher. All right. This could be one of many devices on the network, but we're just going to focus on these two right now. So you put these devices on the network, you turn them on, you start up their software, and they will send out a broadcast. And this broadcast will say, here I am, here's the sources I have available, and all the other systems on the network will pick up this broadcast, and it will store this information in its list of NDI devices that are available, right? It will say, okay, I know who you are. I know what you got available. I know where you are in the network, right? Your IP address and all this kind of stuff. And so now the user goes in and they select off that list. They say, I want to use this source, right? They pick it off the list. So when you do that, then NDI will form by default, a unicast type network connection, and, data will start to flow across that connection. Now, NDI also has the ability to work at two different video qualities. There is a proxy low bandwidth version, and then there's a mezzanine high bandwidth version. And this is something that, depending upon the applications, either one or the other could be asked for, or sometimes it's a user selectable thing. Sometimes it's just the way the application works. So it's a little bit, it's there. I just wanted to let you know they both exist. So in our case here, a low bandwidth version of video is sent across where this can be used to fill like a multi-view window, right? We now can see that there's video coming in from that source device. Now, in the case of our video switcher, we go and put this source on program output. Our program could then say, let's switch to we need the high bandwidth, right? We want to have full quality, high quality looking video, not just the low quality stuff. And it can immediately switch that video to the high quality bandwidth. And at that point, we're, in our example here, 1080p 60, it's pushing about 130 megabits of data across the network from that source in there. Now, if that other device was like a PTZ camera, right, that was NDI HX, that same thing would be about 15 megabits of data, right? It depends on exactly how you have it set, but that's probably a realistic number. And on that same connection that's flowing video one way, we can also be flowing back information like PTZ control and tally information, so that, again, each connection is bidirectional. So it's not just that data is flowing in one direction, but we can be returning data the other direction, so that, it's not, we can have stuff going back and forth between these two devices in here. Now, we've just looked at it for one connection, but obviously the same idea can just be expanded up, where I can have multiple devices coming into a single device, and of course that device could be sending signals back out somewhere else. We can also share a single output among multiple destinations. So like this PTZ camera, maybe I had 3 different people that all needed to see the output of that camera. I could do that as well. So the nice thing here is that when you start to think about it, your network, it becomes like the network video router, right, that we're used to, except it's just your computer network becomes that. And all of a sudden now video can just be pulled up anywhere on any other device on the network that has the ability to see it and has a proper NDI software installed. It's maybe one of those things that you can see it on a slide, but once you have experienced it in practice, it is a game-changing aspect. All of a sudden, it's not like, how do I get video in here? It's just, open this tool, there's the video, I see it. It just becomes freeing in the sense of how video can work compared to what we're used to. So it's pretty amazing from that standpoint. Now, we mentioned that NDI is unicast, and that is the default method of transmission that is used. What that means is that every channel of video that's sent from a device uses the same amount of bandwidth again. So if 3 people were going to view an NDI source, it would use 3 times the amount of bandwidth. The nice thing with unicast, though, it's very easy to set up and work with, so that's kind of why we go with it by default. It is possible. NDI does support multicast capabilities. This would allow you to save that bandwidth where you don't have to send it out like 3 times. You could send out one signal that gets shared out by the switch multiple times. So you could now, I had 20 people that all wanted to view a source. Could I make that happen? Yes, with multicast you could. There are some requirements, though, to make multicast operate correctly, which is why it is not the default. But if you put the right pieces in place, it can be set up and done. Some other aspects of NDI just to talk about. NDI, starting with version 4, has a recording capability that's built into it. We call it native NDI recording. This allows you to take the NDI data stream, write it to disk as a QuickTime file with an NDI sidecar file for any of the additional information that QuickTime can't store. And the advantage of this is that there's no recompression. So the exact same data rate bit stream of NDI can get saved to disk without degrading the footage at all. And because the hard part, which is the encoding, has been done on the source device, right, on the recording device, there's almost no CPU overhead involved. It just takes that data and writes it to disk, which makes it very simple. There are codecs available for all sorts of applications to be able to read and work with these files. We also have a tool called NDI Access Manager that allows you to go in and define your NDI groups and how things are shared. So this is something you can look at. This is what that software looks like on there. And then just a few last things to talk about. NDI does not have to be an island. You can have different, what do I want to say here? Different applications that can exchange NDI between each other. So we have a product that will adapt between the SMPTE 2110 and NDI workflows. So if you already have that or you're looking to combine these together, that's certainly possible. And beyond that, NDI can also be adapted with virtually any other IP format available. So there are workflows out there to adapt it to Dante and AES-67 and SRT and RTSP. So you name it, you have other types of protocols and formats you're working with. It's undoubtedly you can make NDI fit into that workflow as well. The last thing I want to leave you with is let's say you want to experiment with NDI more. You're like, this all sounds great, but how can I get my hands on it and try some stuff? Now, Jeremy's going to show some of these in a minute, but I just want to kind of talk about them really quick. There are a bunch of free applications that you can download, most of them in a package called NDI Tools. And these are applications for generating and viewing and controlling NDI streams. So you can go and get these programs, install them on your computer. They're available for both Windows and Macintosh. All of them on Windows, most of them, but not quite all of them on Macintosh. And then you could start trying this out on your network and seeing how NDI flows and works, and the kind of things you can do with it. So I hope this was informative. I'm going to now pass it over to Jeremy, who's going to give us a little more practical of, I've kind of described the theoretical aspect, but let's take a look at how this works in practice. And then afterwards, we can try to answer any questions that come up. So take it over, Jeremy.
All right. Thanks, Kane. All right, so now I'm live. So Kane had talked about the theoretical aspect of what NDI could be on paper, but in practicality, it's actually how Kane and I are presenting today. We're both running our NDI tools. We both have our NewTek products at our homes, handling everything NDI natively in our basements or our office or wherever we're located, and then sending that information into Teams to handle this call right now. So yes, I'm on a green screen with a backdrop, but all that is being handled with NDI technology as the backbone. So the camera is NDI, the TriCaster is using NDI, the NDI Studio Monitor software that I'm using to mix all this together and then send it over as virtual input as the input signal into this Teams call is all using the NDI technology. I'm remotely controlling my TriCaster from NDI Studio Monitor because of the built-in KVM technology. So again, NDI pretty much is running everything that we're doing for this call from Kane and I's perspective. Now we talk about from a practicality standpoint, a lot of the questions that come up is how do you interface with existing hardware, existing gear? And Kane talked about that before with our encoders and decoders. And so we've got small little boxes just like the Smart Plus IO that can translate SDI to HDMI or to NDI. So we've got conversion gear that handles that. So now existing products can still work in the NDI environment. You're not limited. NDI plays well with others is the whole general idea. You can mix and match boxes, formats. It's not just us. There's a lot of other manufacturers that make products like this as well with different features and different implementations. So you really can expand and grow your workflow and take it a step further in this environment. The idea, something that I've been kind of talking about, is the remote production aspects that NDI can be used to handle events where the gear is in one location, but your operators have to be in another. We're pulling that off with NDI technology, either on a local VPN, where you can remote into an existing network and then have access to control products, or using cloud services. There's several companies that are making NDI-based cloud options. So now you can just log in and based on your subscription level in that cloud, control which device. You have routing functionality. You've got signal processing and things like that, all handling that NDI signal in a remote environment where people are across town, across the city, for me, I'm across my basement. I'm on one side, the gear's on the other. I'm on a local network. We have clients that are using this across the country, across continents, and are moving the NDI traffic around. So there are ways in existing infrastructure to pass that NDI signal to keep content up on air, because right now that's the big goal for everyone, is how do I maintain my on-air signal, or how do I continue to produce content, or now I can't have everyone in one room, how do I access and bring in people remotely? We're doing it right now with this Teams call. There's other applications where you can mix and match other soft codec applications, and using NDI technology now bring remote people into one production from a variety of different methods. It doesn't just have to be Teams. It can be Skype. It can be Zoom. It can be GoToMeeting. There are ways to make that work now. And that does lead into some product discussions that you can reach out and we can talk about that and how to implement it. And that's one of my jobs as a sales specialist for NewTek, is how to implement that on the front side. Kane on the pro services side and with the training is like, okay, now we're going to teach you how to use it. But we're going to make sure that it's implemented correctly out of the gate. That also comes down to the network switch. How is the network switch configured? What is on the existing infrastructure? Because we can play nice with Dante and AES67 and everybody else on the same LAN, but how do we make that work? So we want to make sure that everyone understands the correct procedures, the correct methods on that implementation. And something else that we can handle with the NDI, the various applications, like an iPhone app. Right now, I'm using a PTZ camera that's all NDI in 4K to handle this call, but I can just as easily switch over, and now I'm using a different virtual set element with an iPhone. So now this is an iPhone signal running an NDI app. So now I'm sending it over a dedicated 5G Wi-Fi signal into a TriCaster to handle that. So you're also not limited to traditional hardware. We can now implement cameras on iPhones as additional sources. Desktop applications. The bidirectional nature of NDI means my laptop can be both a source and a destination for production. So that's how I'm running this. I'm bringing everything external from production switchers into my laptop, being able to control that and then send that off. So my laptop is seeing everything from both sides of the signal, which is entirely unique to NDI and how you can leverage that horsepower. So we have a lot of tools, a lot of ways to implement NDI. We're definitely open for questions. We have online demos. You can reach out to your local resellers. ABT has wealth of knowledge to how to implement the NDI in the correct existing environment or future environments. How do you expand? How do you adapt? We have the tools, we have the technology, we have the tips, the tricks, and the experience to be able to pull that off. So I don't want to take up too much of the time that's left. So Mark, if you have anything else, or we can start bouncing around questions internally, I'm fine with that too.
I would say let's start bouncing around questions internally. To those of you watching right now, we do have the Q&A is now open. So I'm looking at it now. I don't see anybody in there. That might be the delay. But feel free to ask any questions from any of the presenters, and they will get back to you with an answer. But for now, Jeremy and Kane, can you start a little banter and questions and try and feed this?
One other thing that that a lot of people have asked as well is when you talk about existing networks, existing workflow, how do you brand? Now, Kane did show the slides with the NC1IOs and things like that. I'm switching sources all of a sudden that I didn't mean to do, so I'm not sure how that's going on. But how do you leverage the conversion gear? We have products that can take 4K, that can take HDSDI, that can handle a lot of other implementations. So that was a camera for some reason that I don't know why I didn't even click that button, but I was still curious. One of my over camera shots of my TriCaster. So our SMPTE box that converts 2110 to NDI and back and forth. That's a great problem-solving tool in this environment where you can't remotely access a 2110 plant. The NDI translator helps with that. Also, existing baseband with HDSDI, converting that into NDI back and forth. We've got a lot of clients that are using those products when they have to do long hauls across either open network or leased fiber. There's several clients here in the DC market that are doing it that way. It just saves them money on MLPS networks or other types of transmissions. They have to move content from one side of town to the other. This is a nice way to pull that off, is using NDI.
Yeah, SRT's become another big way for, especially over the internet transmission. There's SRT encoders and decoders, and there are all sorts of things that will flip NDI into SRT and SRT back into NDI, so you can easily create content, send it over the internet, and then flip it back into a more production format again, and work with it. So I don't know if there's any questions that have come up so far yet, or we can continue to banter.
Yeah, we can talk about a lot of stuff. We can talk about new product development. We can talk about our announcements, not development.
We're not supposed to do base costs, but they do have a question out there that they want to know how much the transcoder costs. So at this point, list cost is fine.
Well, there's a variety of converters.
Yeah, I guess it depends on what exactly you're talking. I mean, there's basically ones that start at hundreds of dollars for like a single channel converter, be it from NewTek or other companies. They go all the way up to, thousands of dollars for like multi-channel, rack mount, dual power supply for redundant, so it all comes down to like what exactly are we talking in here. But I mean, I'll even just say we have a free software that you see in the list behind me, that NDI Connect, if I can point to it there we go. That's free. And that will let you take an off-the-shelf I/O card like from Blackmagic, AJA, or others, and convert it to and from NDI. So hey, I already got an I/O card. Could I use that as an NDI source? Yes. Get this NDI Connect software, and there you go.
So you talk about also conversion gear as well. I'm shooting this shot right now, so I'm actually converting off of a JVC 4K camcorder, converting that to NDI as 4K. Sending that around the network, so now you break the fourth wall. So here's what I'm at. I'm at my desk in front of a green screen in my basement. But we can leverage those little converter products on existing gear, so that way you can handle that remote. You're just long hauling one either fiber cable or Cat6 cable back to a hub, so you don't have to pull all that HDSDI cable anymore because it handles the embedded audio. So there's even companies that have ways to interface with intercom and then put that in that signal as well. So there's a lot of ways to simplify your productions, your installations, especially do things remotely. When you're having to talk about strike and cleaning stuff up and how many cables you have to pull, you can leverage just basic infrastructure that's existing network, or pull your own tactical fiber between switches. There's a lot of different ways to handle this, but this is one example of how to handle existing hardware, converting it to NDI for new applications.
All right, thank you for that. Another question I have is about the time intervals, like in between releases. So what's the interval between like version 4 and version 4.5?
There's no fixed, exact. I would say NDI's been out for about 4 years now. It came out in 2016, and we've had about a new major point release every year, right? We're on version 4.5 now, and it's been out for a little over 4 years, because when version 1.0 came out, NAB 2016, and it was first shown at IBC 2015, the year before that. So, yeah, I mean, as I understand, NDI 5.0 will be the next major release. I don't know when we're going to see that exactly, but yeah.
Okay, moving on to another thing. So we're integrating. You guys are using Teams right now, or we're using Teams, and you're using it as part of it. And Teams does take NDI as a source. Discuss Skype 2 channels and the Zoom interface, and how do you guys work, with that and interface?
So we have again, on the NDI tool software, the list you can see behind me here, there's one in here called NDI Virtual Input. That will take an NDI channel and convert it into a webcam and sound card, right? So then you can go into Zoom, Teams, Skype, GoToMeeting, WebEx, virtually any piece of software, BlueJeans. If it takes in a webcam and a sound card, which all of them are going to, because that's how you get your stuff in, you're going to see these two new virtual interfaces, right? There's no hardware to them, and you would just pick them. So you're going to say, I want my NDI virtual camera and I want my NDI virtual sound card as my inputs, and then using this NDI virtual input, you're just that's what its output is. And then on the input side, you just tell it what NDI channel in the network to pick up, right? I want to take this signal. It could be right off of a camera or the output of a switcher or whatever it would be. And that's how you could feed stuff into those applications. So that allows us to interface with virtually any meeting software. And then for the other way, to get stuff back out, some of them, like Teams and Skype and maybe Zoom, we've heard that Zoom might add NDI output support, but it's not in there yet today. But some of the other ones do. They can output it, but if they can't, so let's say I wanted to use Zoom, again, off of our free list of software, there's one called NDI Scan Converter that will allow you to grab the computer screen and the sound card output of that computer. And so that one piece of software, you can now grab, the video going on the Zoom call and the audio of the Zoom call, and then feed that into wherever you want it to go. And in fact, there is I have a video on how to specifically use those two applications. It shows you how to set them up inside Zoom and Teams and GoToMeeting and stuff like that. That you can watch, and it just takes you through step by step. Get the software, install this, set it up like this. Get this software, install it like this. And So yeah, that is how those kind of applications can be integrated in.
Okay, great. Next question I have for you. What's next on your NDI roadmap?
It's hard to say. We don't normally talk about future development. And to be honest, I don't know what features of it are going to be absolutely in the next one, but just keep in mind that we're continually developing NDI forward. We take an input from other companies and other people. So there undoubtedly will be new stuff, but I can't say what it is. I don't know when we'll see it. So, but I'm hoping maybe before the end of the year, but we'll see.
Okay, understood. Next question I have for you is about timing. Is there any need for inbound timing on the NDI feed, like with PTP or NTP?
So that's a good question, because that is something that comes up a lot, is timing. So NDI, first of all, does not require a PTP clock to operate. It has been designed to operate without that need. Now, I know a lot of people then say, well, then it has no timing and it's going to slip and adjust. But when they work with it, they'll find that that's not the case. There is an internal timing protocol that NDI uses. Now, that is based off it's based off the clocks built into your computer, right? All your devices have clocks in them already. Just like, a camera's got a clock in it for free run SDI. Even if I don't gen lock my camera, it still works, right? And my camera doesn't really slide around by, any measurable amount in that. I mean, maybe a frame at the most, right? As things synchronize, but it's the same kind of concept here. Now, that being said, you can, if you go through the work of setting some things up, you can use NTP or even PTP to align computer clocks accurately together. NDI will take advantage of that, because it's using those clocks for its internal timing. So it's not a requirement it has to be done, but if a client wants to spend the time in setting those things up, then NDI is going to follow along, because that's the clock it's using, is the clock that's already in your computer to, get that kind of timing.
Yeah, so that's one of the bigger differences with Dante, where it does require that clock up front to make everything communicate. We can leverage the backside of whatever system is already set up, because we're using the TCP protocol. It's there. If you sync up your computers with NTP, hey, guess what? We leverage that because you already put it in place. So we can take advantage of whatever the house structure is set up to accommodate. And so it makes us more forgiving, I think, on the network for a lot of signals.
Yep, definitely.
Another question I have for you that would be communication, like intercom between people when they're doing remote. How do you deal with that, and what's being developed to have that control communication?
So there are some companies that are making things on their own and leveraging some of the audio channels that are built into NDI. BirdDog is one that has comms, so that can leverage a audio interface. We can do it as well in the production switchers with our talkback features, with some of our interfacing with Skype and things like that. So there are ways to do it. To have a further in-depth conversation or specifics, then yeah, definitely reach out and we can work with that workflow and see what the best course of action would be.
And that being said, there are other IP intercom solutions already in the market, and there's no reason they cannot run alongside NDI as well. So certainly there are some that use NDI as its backbone, but that is not doesn't mean that other ones can't be used.
All right. Okay. Well, thank you all for your presentations. Excellent presentation. You guys did a great job of this.
Thank you.
It's 2 minutes to 1, so we're wrapping up here. I'm looking. I think that's it for the questions on there. So again, I appreciate your input. I appreciate the presentation. You guys did a great job. And everybody watching, thank you very much for watching, and thank you for attending. And hopefully we'll have another presentation in about another week or two. So everybody take care, have a good week, and have a great weekend.
All right, thanks, guys.
Thanks all.
Thank you.